Good afternoon. My name is Bill Bilodeau, and I'm a developer advocate at Google. So today we're going to talk about improving game performance so that you can make high-fidelity games on Android. The first part will be about common performance issues and the profiling tools you can use to find them. Next, Jung Woo from Samsung will be talking about optimization techniques. And then finally, we'll hear from Duke at Netmarble about how those techniques were put into practice in one of their games, LINEAGE 2. One of the best reasons for making a high-performance game is to have high fidelity. When we say high fidelity, we mean high-quality, realistic, immersive graphics. High-fidelity games used to be limited to just PCs and consoles, but with recent improvements in hardware, it's now possible to play these types of games on mobile devices. Even with the latest hardware, developers still need to be aware of performance issues. Before I talk about that, I want to discuss some of the basic concepts of rendering. Rendering commands are built on the CPU. The graphics driver queues these commands for the GPU to render. Because the GPU is a separate processor, it runs asynchronously with the CPU. This means that the CPU can build commands for the current frame while the GPU renders commands from the previous frame. To avoid artifacts, frames are displayed at vsync intervals. This is every 16.67 milliseconds. If the GPU misses a vsync, the frame buffer is displayed at the next vsync. Too many missed vsyncs can cause stuttering or janks. If the frame is not a multiple of vsyncs, you can see uneven frame times. So, for example, let's say we have a frame time that's about 20 milliseconds. It will display some of the frames every 2 vsyncs and some frames every vsync. To smooth out the frame rate, we can delay the rendering to make the frame time an even vsync of intervals. As in this case, we'll now see the display happening every other vsync. One of the advantages of doing this is also that it saves battery life because you're doing less work on the CPU and GPU. The trade-off, of course, is that you're doing less rendering. So let's look at some of the issues that can cause slow performance. CPU activity can be the cause of slow performance. A CPU bottleneck is when the CPU can't keep up with the GPU. This means that the GPU is waiting and idle, waiting for commands to be sent to it. This breaks the parallelism between the CPU and the GPU, which makes it less efficient. Some of the common causes of CPU bottlenecks include too many draw calls. And this is because with every draw call, there's a certain amount of driver overhead on the CPU. Single threading can also be an issue. This is when you put too much on one thread. For example, rendering and game simulation on the same thread. Now, both of these could be improved with the Vulkan graphics API. If you remember last year at I/O, we announced Vulkan on Android devices. Vulkan is a more explicit API than OpenGL, and it's closer to what the hardware is actually doing. This means it has less overhead per draw call. You can also do multi-threaded command buffers building. So another problem that could be causing a CPU bottleneck is too many state changes, and this adds to the driver overhead. The GPU can also be a cause of slow performance. GPU bottlenecks are when the GPU is taking too much time to render. The driver can help this by buffering commands for a couple of frames, but when this queue gets full, the CPU has to just wait. As with CPU bottlenecks, this breaks the parallelism between the CPU and the GPU. Some of the common causes of GPU bottlenecks are fill rate. on modern phones, the resolution is very high. And it's going to be worse if you have long fragment shaders. One thing you can do is render to a lower resolution buffer. Another problem could be high polygon count, especially when you have very complex geometry. Buffer synchronization can also be an issue. This is when the GPU has to wait until the CPU is done writing to a buffer that's shared between the two. And also too many state changes, as with CPU. Too many state changes can be a problem. These hardware state changes can cause the graphics hardware to flush the pipeline, which introduces a stall. Overheating is a common issue with mobile devices. As the temperature goes up, the system has a governor that makes the frequency and voltage go down. This is called thermal throttling. As the SoC cools, the frequency and the voltage go back up again. But then this leads to unstable frame rates. Developers should not overlook long load times. This can cause people to stop playing their game. Cold loads are when the game needs to load assets into memory. They may need to process assets. For example, you may need to decompress assets. You also may need to compile shaders. This all takes time on the CPU. You might try caching to avoid duplicating this work every time you load. Battery performance is also important. This affects how long your users can play the game. Unfortunately, high-performance games tend to use more battery. Vulkan can also help with this because it uses the CPU less. This is important because the CPU runs at a higher clock speed than the GPU, so it uses more power. To detect issues like this, there's several tools available. Unfortunately, one tool may not be enough. For example, if you're doing low-level profiling, you may want to see the hardware counters, like on the GPU. This requires vendor-specific tools. So the first one we'll look at is Systrace, and this is from Google. Systrace is a system trace viewer, and it shows threads executing on the CPU. The longer the trace, the more time is being spent executing. You can use custom trace events in your game to see how different sections of the game take, how long they take. This can also show you how much concurrency there is within your game. One thing you can do with Systrace is see system activity relative to your game and see potential dependencies that could be causing things to run slow. For more information, you should watch this session that was presented earlier at I/O, and we have it recorded on the I/O website. Simpleperf is a CPU profiler from Google. It shows the percentages of time spent in various parts of the game. For example, we can use it to find where the percentage of time spent in shared libraries, and that way we can tell where most of the time was spent. We can then look at, say, one of these shared libraries, and then see how much percentage of time was spent in each of the functions. Now, one caveat with Simpleperf right now, it's not very easy to use. It requires a certain amount of setup, and it's only command line. But once you get the hang of it, it actually produces some valuable information. Other profilers include the hardware vendor profilers. For example, Qualcomm has a Snapdragon profiler, ARM has Streamline, and NVIDIA has the Tegra system profiler. Game engines also have profilers. For example, Unity and Unreal have built-in profilers. And also, there are graphics debuggers, like RenderDoc and Google's Gapid. These tools can capture API calls that can help you find inefficiencies in the API. So here's an example of profiling a game using the Qualcomm Snapdragon profiler. Let's see if we can find out where the bottleneck is. It shows CPU traces similar to Systrace, and it also shows GPU traces. So on the lower part of this display here, we can see the CPU scheduling with colors corresponding to each thread. On the upper part is the GPU activity, where the blue bars represent when the GPU is rendering. Now, the first thing we'll notice here is that the GPU is idle for a long time. That's bad. In contrast, the CPU core 1 is busy almost the whole time. This is a classic case of a CPU bottleneck. Now, we might be able to multi-thread this, but in this case, this is the render thread, and OpenGL, you can't do multi-threaded rendering. So let's take a closer look at what's going on by doing a frame capture. Now, frame capture shows us the API call similar to debuggers like RenderDoc. And if we look at the frame capture, we're going to look at the draw calls. There's a lot of draw calls going on here, almost 1,500 draw calls. That's actually a lot too much for a mobile CPU. Remember, with every draw call, there's CPU overhead, and that all adds up. So one thing we can do is we can draw less, or we can batch these draw calls together by the ones that have the same materials, batch them together, and then we'll have fewer draw calls, which will improve performance. Our next speaker is Jungwoo Kim, and he is a principal engineer at Samsung. He will talk about game optimizations.
Thank you, Bill. Well, I'm Jungwoo Kim. I'm managing GPU driver, graphics performance for Galaxy product, and also reading Kronos Standard and Game Dev Tech in Samsung Mobile Division. So I will talk about what should be the right direction of gaming optimization and also some best practices from our real experiences. I think you all know about Samsung is a good phone maker, but you may not know about working with many game developers for improving Android ecosystem entirely. So we are working with over 50 game studios and developers for around 30 game titles with various kind of way under our new game developer support program, Galaxy Game Dev, from March last year. And thank you, partners, and I also strongly appreciate my team in Suwon HQ, UK, US, and Ukraine, to support partners with endless overnight work with many beers. During our supporting game developers, we also have questions about what would be the real goal of gaming optimization. Just keeping stable frame per second like this smile mark? But it looks like it's getting boring by frame, and doesn't look like it will bring high fidelity to any games. Like this, quality level also would be another point we have to take care. The resolution, scene complexity, and more visual intensive graphics. The games will have more rich content with better quality, and this can make games fun to play. But traditional optimization is just trade-off between quality and performance always. If we want to get more frame per second, then should expect less quality. Low content quality is the reason of boring. Users will leave easily even the game is still keeping 60 frames per second. Some graphics extensions will give you a way to manage both quality and performance, but it works only with some corner cases only. Then how we can make this? This is even a year ago Vulkan demo prototype what we shown to you during our S7 Unpack. Now, how can we chase both quality and performance at the same time with more general use cases? I want to show one simple example from hardware side, because we're a phone maker. The thermal throttling is one of the critical problems of phone maker like us. And Samsung has a good structure of managing thermal from AP chipset, but stuck in certain level in nowadays. So we optimize the structure of a heat spreader and change the interface material has a 9 times better conductivity between heat spreader and AP chipset. So now Galaxy S8 has a 7-degree RAS AP chipset thermal in worst case scenario, and this gives more comfortable experiences to user when they play games. This is not just trade-off, but making fundamental changes to breakthrough jump. Then how we can do similar things with software side, not hardware side, chasing both quality and performance? We strongly believe the answer should be Vulkan. Vulkan is open standard cross-platform new generation graphics API from Kronos Group. It's really thin, lightweight, predictable, portable, and cacheable. It supports precise explicit control and deliver a bunch of great tools to optimize your games. We many times face at nothing do more situation except dropping quality with old API GLES. OpenGLES is easy to use and can make quick prototyping, so it's still usable for some use cases. But we believe that Vulkan is breakthrough jump like I showed to you with this hardware example in software side. First, low CPU overhead. Vulkan is thin structure, so driver can has very small overhead in CPU. The over 100 draw calls can easily spend some milliseconds with the GLES, but Vulkan doesn't. This will give you some margin on resources, and you can use this for your own purpose, like better performance or longer battery life. We implemented many POC-level Vulkan samples to prove Vulkan is really good thing to our marketing team. You may not even imagine how many samples we implemented before S7 launching for convincing internal people. This is a regular demo, which one of sample which our team developed for around September 2015. You can see left side Vulkan uses similar or less CPU, but renders almost double or more frame per second than GLES. You may think this is just demo, sample, or corner case, but Vulkan works with the real games too. Here is Vainglory. We have been working with Superable backup since April 2016. You can see the right side of Vulkan shows much stable frame per second without big frame drops. We see around a 20% performance gain, near 60 frame per second in even throttling situation with the Galaxy S7. Second, explicit control. You can manage precise command buffer submit from one of each random pass or one for some groups of random passes. You also can change dependence between each pipeline stage with the pipeline barrier function. If you give barrier between fragment to birth stage, then every birth stage will wait until finishing previous fragment stage. If you change barrier between every fragment stage, then there will be no waiting between fragment to birth stage anymore. You also can manage the memory more precisely. You can use different memory type for each purpose, and this will give you more optimal memory management. So this is a DS5 streamline capture of a certain game we are working with. First capture shows original GLES, and there are wide gap between each random passage coming from CPU overhead of some hundred draw calls for each random pass. 12 milliseconds for GPU processing is required. Even after we port everything with the Vulkan, but can see captures number 2, worse performance like 24 milliseconds. This comes from using wrong pipeline barrier. The number 3 is now showing the proper barrier, and then it takes just 12 milliseconds. Third, uniform. Uniform is one of the critical part of graphics programming. This has a basic intention of interaction between CPU and GPU, so it can give quite big impact to performance in many cases. But you can manage uniform buffer in Vulkan to get less or better performance. We developed 4 different incremental implementations from brute force to idle condition of dynamic offset way. And you can see the performance differences from the 1 frame per second to 43 frames per second. Let's see the video clips from our 1250 Throttling sample implementation like this. Vulkan gives you ability to control things precisely, but you may also feel it's hard to handle. But you don't have to worry about the handle by yourself all the things with the Vulkan implementation, but the game engine support now Vulkan. We worked with Epic Games from mid-2015 for the UE4's Vulkan supporting. They released the 4.12 as first Vulkan RHS support UE4, and recent release Vulkan support is now getting better and better. We've worked with Unity for supporting Vulkan in Unity 5 since September 2016, and 5.6 released recently as the first official Vulkan renderer support Unity version. So wrap up. We believe Vulkan is the answer for chasing both quality and performance to develop high-fidelity game in Android from many experiences with our partner game companies and developers. It can give more performance, longer battery life, less heat problem, more visual quality to your game. Look a little bit complicated, but still game engine will help you can use it even without any understanding of Vulkan implementation. One more thing, Vulkan will help more with mass mainstream devices. We tested with one of Vulkan games with both Galaxy S7 and A5 2017 model, then see more performance gain with the Galaxy S5. Even flagships show better performance, but Vulkan will boost more with mass product. So Vulkan is not only flagship feature anymore. We are all ready to develop high-fidelity gaming, Android devices, technologies, platforms are all set it up. I want to introduce Duke about the LINEAGE 2 Revolution case study.
Okay, thank you. Yeah, developing LINEAGE 2. Yeah, what Netmarble has learned. Okay. Hi, my name is Duke. I'm a VP of Marketing Intelligence at Netmarble. And I'm here to introduce LINEAGE 2 Revolution and to share Samsung and Google and Netmarble co-working what kind of result we made with you. Last year, I did a short speech like this one, but that was a part of my bad memory. So at this time, not to make that kind of thing again, this time I prepared many video clips, so that will be not make you bored. So before talking, I want to show you a very short clip of LINEAGE 2. Yep. Yeah, one thing I want to tell you is this is the actual gameplay video on a mobile device, maybe Samsung S7, maybe. I think our title could be called a high performance game by graphic quality, at least. But to my boss, the most important thing may be the high performance means high KPI. So I want to share what kind of KPI we achieved in Korea. Yep, record-breaking success. LINEAGE 2 Revolution was a huge success. Just 30 days after launch, this title achieved over $176 million US only in South Korea. We just opened this title in South Korea yet. It took only 17 days to earn $100 million US, and a huge user base, 5 million monthly active users. That is the same amount as 10% of South Korea population. Every number is recorded in the South Korea mobile game industry. And it recorded over 2 million daily active users. We do our best to keep this number. Because the Lineage 2 Revolution is MMORPG, the max number of concurrent users is very, very important. And it recorded 740,000 5 weeks later after launch. It's a huge amount of people. Finally, according to SuperData research, Lineage 2 Revolution was the #1 title in global mobile market only in February, just 1 month, but we are proud of it. I said, we just opened this title only in Korea, and the Korean mobile market is not small, but not big. What I want to say is #1 in Korea doesn't mean #1 in global, but February, we make that. To make this kind of result, when we planned to develop this title, we had 3 major goals to make it to be the next level title. The first thing is AAA console graphic quality. Yeah, we just want that kind of graphics on the phone. The second thing is best open world environment. In Korea, before Lineage Revolution, the major genre was action RPG. And action RPG means every user tried every stage for enjoying game. And that make many people bored. So we thought open world will be the answer for that. And massive castle series. Massive castle series is very important. Why that is important is to extend our title lifespan. Making new content is not enough. It takes too much time, it takes too much money. So to extend our lifespan, the most important thing is making users build their community based on our content. That content is castle series. I want to show you 2 clips. One clip is introduction clip, and the other is actual gameplay video. Yeah, this is the introduction video of Castle Series mode. The one thing I want to tell you is to enjoy this kind of good content, every user have to build their own clan and have to discuss about how to win, how to beat the others. And that means to enjoy this one, the users have to make some their own community. So this is actual play video. Next slide, please. Okay. Yep. It's awesome. You can enjoy this kind of content on your mobile phone, real-time battle with up to 200 players. But that is not easy. There are so many problems we have to solve. Something like the stable frame rate, and the thermal problem, and the battery performance, as Bill said earlier. So how to make that kind of thing? We thought Vulkan can be one of our solutions. So we expected to, with Vulkan, we can solve the frame rate problem and also battery problems. So this is the actual example. The upside is using Vulkan. The downside is just using OpenGL. You can check the frame rate. The Vulkan version was more stable. This is another example. And because of frame rate is more stable, we can add more effects. This is the original version of LINEAGE 2 Revolution. This is using OpenGL. You can see very clear screen. And we add depth of field effect. They make the user feel the depth of the environment. So we just get started, and we have to improve our graphics to maintain our position in Korea. And we plan to launching this title outside Korea. And you can enjoy this content maybe in this year. That means we have to make our title run well on low-end device with keeping our edge. And we believe we can do that with Vulkan. Thank you.